let's head into it and calculate some interest rate here. So I'm going to run through these because the examples end up all being quite similar. So let's just fade that out a bit. So we've got 20,000 Rand invested in shares on the stock market, and after 8 years, the shares are sold for some 52,000 Rand. Calculate the compound interest rate per annum that would provide the same return. So in other words, for this one, it's almost like we've put 20,000 Rand in, and we've got 52,000 Rand out. What would our interest rate be to give us the same return? So 1 plus I to the n. That's our general formula. Remember that F equals P 1 plus I to the n. So all we have to do is work backwards and go, okay, well actually n we know is, what's n? How many years? Well, they're 8. So we're going effective interest rate annually, so therefore we can do that. So I'm just going to work you through this one and not ask you, what do you get? Yes, with that tone, right? So let's get our calculator out. There's mine. There we go. Look at that. So we've got 52,000. And first of all, we're going to need to divide that by 20. 1, 2, 3. And, with our calculators, that's up to you if you do this piece by piece. So, at the moment you've got, okay, so 13 over 5 equals 1 plus I to the 8th. Okay, but wait, we just want to kind of ease our way into getting to I. So I'm going to show you a few extra steps along the way. So we need to take the 8th root of each side. And so calculator somewhere, it needed to do that first, right? It's feeling so left out. So we need to take the 8th root. So if you'd done this in kind of one step, you might have gone, where's that button? The 8th root of that and got to that step, or you might have, taken the 8th root of aunts. It doesn't really matter. So at the moment, what our equation says is 1,126 blah blah blah. Just don't round off that. Definitely don't round off yet. Is 1 plus I. And now we need to subtract 1 from each side, and we'll get what I is. So back to the calculator, and we go -1. So you might have just gone -1 from aunts, but there I'm leaving it purposely up on the screen to show how you might have gone there in one go. So 0,12 blah blah blah. And let's go over here and go, therefore I is approximately, we want to take that whole thing, and again, you would have just typed 100 times 100 for your aunts, but I'm just showing it all in one step to go, okay, so that's 12,69%. 12,69% over there is our final answer if we've rounded off. But wait a second, that's compounded interest. Now the question is, how often is that compounded? Maybe I'll give you some hints. Is it compounded monthly, semi-annually, annually? What is it compounded? Well, it's compounded annually, because it's almost like we had this thing here over 1 annual. So therefore, there is our final answer. Okay, so let's run into the others, because they kind of, as I said, these kind of feel a little bit same, which is quite cool, makes them easier. So goodbye calculator. Aww. And so we've got 50,000 Rand is deposited into a bank account, left for 6 years. At the end of the 6-year period, the accumulated amount is 88,215 Rand and 14 cents. If it's compounded monthly, determine the interest rate. So just out of interest, it's only the second one you're ever doing in your life. Maybe you did some before, but I doubt it. How are you feeling on solving this one right now? Can you give it a bit of a go? And write as much as you can there, actually, just to give me a sense of how you're feeling right now about just trying that example. Okay, well, that'll make for some interesting reading. We're going to use that same formula. F equals P 1 plus I 1 plus I to the n. And so our future value, I always think of it this way. We've invested 50,000 Rand. We've got 88,215 Rand and 14 cents out. And we've got 1 plus Now it's compounded monthly, so it's going to be over 12. So now we've got I, we don't know what I is, and it said that it was 6 years. But now remember, I'm just going to do some working above my head here, that we've got 6 years times 12 months to give us the compounding periods. So that's kind of the only maybe little extra bit to think about in this one. So, now you head into it in the same way that you did before. And you get your calculator and you go, I'm going to do it step by step, not in one go this time. But I'm not going to write down all the steps. Keep an eye on them on the calculator. 88,215.14. And I first want to divide it by 50,000 because, it's like divided by 50,000 divided by 50,000, right? We're just solving that, so we'll get the next bit. But now I said I wasn't going to write all those steps. Now I'm already. Divided by 50, 1, 2, 3. Okay, now we've got 1 plus I over 12 to the 72. So we need to take the 72th. What is it? 72nd? 72th. Which one is it, but which one sounds better? I suspect those are two different answers. So the 70, the root of this thing here, because we're doing it to both sides. Now that was once in the calculator, because it was the most recent thing. So now what we've got so far is 1 plus I over 12. Right? So we need to subtract 1 from each side of our equation, minus 1. And then we need to times it by 12. Times 12. And that gives us I, which seems like a really, really small value, right? So we're like, wait, 0, I equals 0,095, blah, blah, blah. But wait a second. That's because we normally used to seeing I as a percentage, which means we need to take that and multiply it by 100 to get 9,5%. If you say 9,50, I don't know how many decimal places. Okay, so just to round off that question, how was that? Now this one can be a briefer answer. How was that? Okay, so 2 more examples, and they like the same example. Determine the interest rate per annum compounded monthly that would result in an investment doubling in value over a 7-year period. So again, but this time briefer. Ideas. Do you have some ideas to solve this? If so, what's your answer? And yeah, give it. What ideas have you got there? And how are you feeling on this? Okay, well, this one says, wait, it doubles. So there are 2 ways we could think about this. We don't need that. We could either say, well, just choose some random number. Let's say we put 10 rand in and we got 20 rand out. Okay, 1 plus, well, let's say interest rate per annum. So we can just go I to the n, I is 7. Because it's like we put 10 rand in and got 20 rand out. Because in our next step, we're going to divide both sides by 10. And therefore, we're going to have 20 over 10 is 2 equals 1 plus I to the 7. Now, for our second option of looking at this, you might say, but surely that would be different, if you invested 100 rand and got 200 rand out, or something a bit different. Or you might have said, no. I like doing this with variables. I want to say, let's say you put x in and you get 2x out. And then it should work for anything. 1 plus I to the 7. So in this example, well, we want to divide both sides by x so that those cancel, and we've just got 1 plus I to the 7. And 2x over x gives you what? Well, gives you 2. So, clearly works for anything. And for these examples, whichever one you're more comfortable with, choose an x, make it x and 2x, or just choose a number. 10 becomes 20, 100 becomes 200. I guess 1 becoming 2 would have been even easier. Okay, so let's go ahead, and I'm just going to solve us through here and go, well, let's take the 7th root of each of these. So that's the 7th root of 2, whatever it is, and that's 1 plus I, and then we're just going to have to subtract 1 in the last step, which will give us I, and then, of course, I as a percentage is that thing times 100. So, in other words, on the calculator we had 2. So 2 was where we're at. We took the 7th root. I'm going to do this in one go, just because we can. And go the shift 7th root of 2. That was that. And then we subtracted 1. I don't know why I'd had these. I thought we'd have to... Oh, I know why. Because then what we want to do is times it by 100 at the end to get 10,41%. I don't know what this was. 0,1041, blah, 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 probably. Okay, so there we go. Ready for our last example. I hope so. Determine the interest rate compounded quarterly that will result in an investment trebling in value over a 15-year period. So the question is, not value, what does it mean for something to treble? Well, I think it means that it times by 3. So again, either way, you could either go, well, you've put x in and you get 3x out, because you know that 3x divided by x gives you 3. So you know that that's going to happen next. Or you might have said, I put 10 Rand in and I got 30 Rand out. Still, when you divide by 10, you're going to get 3 on the left-hand side. Okay, 1 plus, and this is happening over a 15-year period. But it said that it was done quarterly, so we've got a 4 here. The interest rate we don't know. So let's just throw in a good question. How many compounding periods are there? Well, it's happening quarterly and it's 15 years. So 15 times 4, 60. Like 4 quarters, never mind. I was going to say 4 quarters of an hour, it's 60. Anyway. So, then we can just solve our equation. 1 plus I over 40, not 40. I'm thinking ahead here to the 60. Okay, take the 60th root of each side. And let's go and do it here and say, well, we've got 3. We want to take the 60th root. And yes, I'm kind of sometimes doing this in one go, sometimes doing it as we go along, because I'm purposely showing it. It doesn't really matter. As long as you get it right, or as long as I was going to say consistent, as long as you think about it. So here we go. We can go minus 1 equals times 4 equals times 100 equals 7,39. I is approximately 7,39%. In other words, let's just kind of think, what did we work out? If you invested some money and wanted it to become 3 times as much 15 years later, you would have to invest it at 7,39% per annum compounded quarterly. So put in your 1,000 Rand now and you're going to have 3,000 Rand in 15 years' time. That's pretty good, right? Is it good? I don't know. Okay, well, that is that. I think, didn't we have some music on the go here? Let's bring that back up. Where's our music? Didn't we have music? There it is. Cool.